Alright, welcome to part 2, and hopefully I can finish it up in this part about this whole thing on compositions. Yeah, we just got to talking about why reflecting twice over parallel lines makes a translation of twice that distance in the direction of the first line to the second line. So if I was to reflect over this line first and then this line, the translation would go that way. Alright, notice about this, after you reflect something twice, notice you're going to get the same orientation as when you started. That's what it looked like in this thing, remember. From this first blue, dark blue quadrilateral to this green one, it hasn't been flipped over. It was flipped over once and then flipped over again, so of course it's going to look like the original in terms of orientation. Okay. I don't know if I said this yet, but no matter what happens, oh yeah, I'm about to say it next. Whenever you do two isometries in a row, remember isometry is a transformation that makes a figure that's congruent to the original. If you do that twice, guess what? You're still going to get an isometry. Okay, so there's actually a theorem in the book, 14.6, that says if you do an isometry and then another isometry, the start to finish thing you've done is, guess what, an isometry, because it's kind of like transitive for congruence. Okay, so let's do another one. Let's do, well, what if those reflections intersect? Here we're going to have intersecting reflections. You're asked to reflect this over E first. Oh, I'm sorry, I wrote E then F. I need to change that. Give me a second. See, sometimes I even get that wrong. Good thing I haven't printed this yet. So we're going to reflect triangle ABC over E first, so it's going to kind of go up in this neighborhood somewhere, and then that image we're going to reflect over F, and it's going to come down over here. Let's show that on sketch. All right, the first reflection is going to show over the line E. It's going to look something like that. I made it gray again because it kind of doesn't, it's not going to be our final answer. And these are going to have the labels, of course, A prime, B prime, C prime. I didn't do that in the last example. Probably should have done that. Okay. And then, again, that's just a reflection. We know how to perform reflections. You should be good at that by now. Remember, this is to find with a ruler how to do that. I just measure till I get perpendicular distance to the line, then keep going that same distance so that midpoint's on here. And if I reflect that whole thing now over F, it's going to look something like that. And I might as well label the points, A double prime, B double prime, C double prime. This one's a little bit harder now to sort of predict what's going to happen, I think. Just to my eyeballs, this doesn't look as easy if I kind of wiggle what's going on here. What happened to this thing to go straight to this final version? And yeah, it could kind of cross the line, or it could be anywhere related to the lines when it starts. But overall, there is actually a very predictable relationship between where this started and where this one went over here. Let me show you on the pre-made one that someone else made. Okay, so this one, I'm going to reflect it first over the blue line. It looks like that. Reflect that one over the green line. It looks like this. And notice this final one that we see is the same orientation as this dark blue one. This one, of course, is backwards from the original dark blue one. That's backwards, and we flip the backwards one. We get a one that could be stamped with the same stamp as this. It's we have like a right-handed flag here and a right-handed flag here by flipping this left-handed one over. Anyway, if you can't tell what that's supposed to be, guess what? It's the same as taking this thing and rotating it like that. It's rotating from the original remember, for rotations we need a center of rotation and we need a degree of rotation. The center of rotation here, relative to the two reflecting lines, I don't think is a big surprise, but the thing here, I have to move these on the screen so you can see them. The angle between the lines, if I was to measure this, oh, it's almost 60. Measure this angle here that it's rotating across. This angle here is about 60 degrees. So guess what? This rotation turns out to be 120. Now, why is that exactly double? Well, it's kind of like the proof we saw last time. There's this, by definition of reflection here, there's the same angle, D to intersection point with the line. That line, intersection point to E, that's going to be the same angle because it reflects. That same kind of thing happens over here. We get an angle and its reflection equivalent kind of thing over here between E and F. So the overall angle from D all the way to F is two of these little angles and two of these little angles. So it's double of one of each, which would be between these lines. So that's a really fast kind of discussion of that proof. There's proofs in the book, and again, it doesn't matter where we start. Now this starts to look really wacky, but if I move this original thing around, it's still, let me reset that whole thing, it's still, we reflect it once over the blue line, reflect that one over the green line, and start to finish, that is a rotation of that far in that direction. It's the same rotation we were doing before. Why is it so much slower? I didn't change the line, so it's still a rotation in this direction from blue to green. From blue to green, twice as far. So this went this way twice as far. Here, this angle of dotted lines is double as big as this angle of reflection lines here. Now, how do we know which way to go? If we had done green line then blue line, or blue line then green line, of course, I think you can probably predict we're going to get rotations that go in opposite directions. How do I know which one's the way this is going to go? In fact, let's just do this. Let's move things around. Let's make things totally different, because you're going to have questions like this. Okay, we just see this. Think about what the rotation is going to look like. That that goes green then blue. Okay, green then blue. Is that going to be clockwise or counterclockwise? Because if I start at green here and go, okay, I'm going towards. Sorry, it's blue first, right? Blue is the first reflection. Yeah, blue is the first reflection. So I'm going blue then green. If I go blue then green, am I talking about this angle? Am I talking about this angle? Am I talking about that angle or that angle? Well, the way it's defined is you look for the acute angles. Remember, because when these lines intersect, they're going to have two different size angles. There's an acute pair and there's an obtuse pair. Look at the acute one, either this one or this one, and from line 1, which is the blue one, to line 2, the green one, that direction is going to be the direction we're going. So from blue to green across acute is clockwise in this case. So this rotation, yeah, it's going to go clockwise. It's going to go clockwise twice whatever this angle is. And I don't know why that's going so slow, but it's going to tell me what the angles are. Sometimes Sketchpad gets confused with positive, negative. If you converted this to the, I'm trying to say the acute angle version, Sketchpad just doesn't quite always like measuring angles the way we want them to. But if I measure this angle this way, how come I can't? Oh, there we go. Yeah, it's going to be half of 63.8 is half of 127.5. The positive negatives, again, it gets confused sometimes, but use your human eyeballs, you can realize that, yeah, that's a negative angle of rotation. That's a negative angle of from line 1 to line 2. Let's change that slightly. So, oh, I can't move it with that. Let's change it so we have an angle going that way, because now the acute angle from blue to green is actually a positive rotation. Oh, sorry that that's off the screen. Can I move everything so you can see it better? Oh, ooh, why did I do that? Can I just like select all kind of? Okay. Yeah, now this line of reflection. Oh yeah, the reflections look really cool now. There's the first reflection. It's just right there. The second reflection takes it way over here. And that equivalent rotation is in the direction of blue to green, line 1 to line 2, twice as big as this angle. So this angle looks pretty big. It looks like it's about, I'm guessing it's about 70. We'll find out here in a second. Yeah, it's about 70, and double that angle is going to be about 140. Okay. So again, yeah, in words here, what's going on here is whenever you reflect over two intersecting lines, you're going to get a rotation, and the rotation is going to be, now think about what we need for details about a rotation. Details about a rotation, we need center and we need direction and degrees. The center is going to be, remember, it's just these two lines that produce that rotation, so we need everything we can know about the rotation needs to come from these two lines. The center of the rotation, the center of the clock face is going to be D. The amount of rotation is going to be twice as much in the same direction as the directed angle from line 1 to line 2. Now notice if I started here going, because this is line 1 and this is line 2, if I thought about going that way, it would be the same rotation. If I went twice that angle this way, it's the same rotation as thinking about it on this side of the intersection, so it doesn't matter. We're just thinking from line 1 to line 2 across the acute angle. I can't go from line 1 here to line 2 here because that's obtuse and that's going to be weird. Don't think of it that way. You're going to get rotations that are crazy angles, and it may work some of the time. Anyway, think about that as double the rotation through the same direction as that acute angle. And then, of course, if these two lines are perpendicular, think about what happens. There's a little corollary here. If those would be perpendicular, there wouldn't be an acute angle, but there'd be 90. And the rotation through double 90 would just be a rotation of 180. So it doesn't really matter which way you go. You're always going to get a half turn. And that's going to happen a lot on coordinate axes problems. If you have to reflect over the y-axis and then the x-axis, if they're perpendicular, it's going to be a half turn, so it doesn't really matter which one you do first. In general, though, it does matter which one you do first, because if you reflect over one line, line 1 then line 2, or line 2 then line 1, you're going to get rotations in opposite directions. Okay, so here's other nice problems you're going to have to do. If you're faced with this, draw two lines so that you produce a rotation of negative 80 degrees. Well, to produce a rotation of 80 degrees, let's worry about the negative later, I'm going to need lines that intersect at 40 degrees. So you'd use your protractor. Basically, you'd essentially make lines that intersect at 40 degrees. Or if you can't, if you don't have a protractor, look there, I just made perfect lines that intersect at 40 degrees because I said so. And the center of the rotation will have to be P, so we'll label that as P. Now I just have to make sure that my rotation that this produces, because this is going to produce an 80-degree rotation no matter which way I go first. But if I pick line M to be here and N to be here, I have to be careful about which one's which, because the rotation is going to go in the direction of that smaller directed angle. So I want N first, then M. From N to M has to be negative. Negative, of course, is clockwise, so I kind of want that to go that way. So if the rotation is supposed to go this way, I got to make sure that my first line is this one, and my second line is this one, so the rotation goes in that direction. If that's a 40-degree angle, and this is N and this is M, we're going to get a rotation, and we go N first. Remember, that's the one on this side. N to M is going clockwise across the small angle, so that's going to make a rotation this way, and of course center is P. Great. And then on the coordinate plane, draw two lines such that if I reflect over Q and then reflect over P, I'm going to get a translation. So if that's true, of course, I'm going to need parallel lines. I guess I could mark this here. So as soon as it said rotation, I knew they needed to be intersecting. As soon as it said translation, I know they have to be parallel. Okay, and parallel, they're going to have to, when they're two parallel reflections, of course, they're going to make a translation. And the translation they make, of course, is going to be double as far apart as the lines are. They're double as long as the lines are far apart. Say it that way. So I want this translation to be a translation of 6, so the lines should be 3 apart. You can think about that like this. But if I drew them like this, I'd get a translation that's left or right 3 degrees. I'm supposed to have a translation that's up by 3 units. Sorry, 3 units. So my lines better be horizontal lines that are 3 units apart. Doesn't matter where I put them, as long as they're 3 units apart. I could have put them there. I could have both put them down in negative. I could have one on the axis. It doesn't really matter. The point is that they're 3 apart. And if it's supposed to go up, of course, left and right wouldn't work. It's supposed to go up. I need the direction of the lines to go from line 1 to line 2 needs to also go up. So Q should be the one on the bottom. Then from Q to P is upwards, and we're in good shape. This is a space of 3 units. So that's going to produce a vector of 6. Okay, I don't need to keep talking. That's been almost a half hour. Thanks for paying attention, and we'll see you in class.